Hey everyone, and welcome to this explainer. Today, we're diving into a massive, completely invisible pollution problem that's happening right under our noses. I mean, literally right under us. It's an environmental challenge so perfectly hidden in plain sight that every single time you hit the road, you are contributing to it. And yeah, you're probably doing it without even realizing it.
So, let me ask you a question. What is one of the world's absolute biggest sources of microplastics? Seriously, take a second to think about it. You're probably picturing, plastic grocery bags floating in the ocean, or maybe those tiny microbeads they used to put in face washes. But the real answer? It isn't in your kitchen, and it's not in your bathroom. It is actually tied directly to your daily commute. Crazy, right? Okay, let's get into this.
1.327 million metric tons. That is the jaw-dropping amount of tire wear released into the environment in Europe alone in just a single year. And over in the US, it was over 1.1 million metric tons in a similar time frame. To put that into perspective, that's like thousands of fully loaded cargo ships worth of dust. This unseen issue is absolutely monumental in scale. It honestly makes vehicle tires one of the absolute largest emission sources for microplastics globally.
Section 1. The invisible plastic problem.
To actually unmask the culprit behind those staggering statistics, we really just need to look at the streets we drive on every day. As scientists perfectly summarize it here, the generation of tire wear is an inevitable outcome of the friction between the road and the tire. And this right here represents a fundamental paradox of modern transportation. See that friction? It's exactly what gives you grip. It's literally what allows you to slam on the brakes safely to avoid an accident or to steer precisely around a tight corner. But that very same life-saving friction is simultaneously breaking down your tires and the road surface into microscopic, persistent, polymer-based microplastics. It's a real catch-22.
Now, scientists have a specific name for this stuff. They call it TRWP, which stands for tire and road wear particles. When the rubber meets the road, it doesn't just, shave off pure rubber. The intense heat and friction cause an instant agglomeration. Basically, it's a microscopic mashup of the tire tread, bits of pavement, minerals from the road, and even brake dust. And what's absolutely crucial to understand here is that these particles are dense. Because they're significantly heavier than water, they settle rapidly straight into our environment, rather than just floating away on the breeze.
Which brings us to Section 2, the anatomy of TRWP. Let's zoom way in. Take a look at this scanning electron microscope image we've got on screen. This shows actual TRW collected from a tire test bench. Notice that elongated, almost cylindrical shape of the particles? It's kind of like a microscopic log. And if you look really closely, you can actually see how they have incrustations of road materials and minerals embedded right into them. These complex, hybrid plastic particles are entirely invisible to the naked eye. Most of them are coarse or fine particulate matter just slipping completely unnoticed into the world all around us.
So where exactly do they go once they fall off your car? Well, the journey of TRWB basically happens in 3 stages. First, they get launched into the air by your spinning tires. But because of that high density we just talked about, they settle really rapidly right back onto the road surface. Step 2 is mobilization. Get this, it only takes about 5 millimeters of daily rainfall to wash these heavy little particles right off the asphalt. And from there, the vast majority, we're talking between 66 and 76%, accumulate directly in our roadside soil. Meanwhile, another 8 to 40% flow straight into aquatic systems through stormwater runoff.
All right, moving into Section 3, the EV weight dilemma.
Now we arrive at a fascinating and honestly almost ironic twist in modern transportation. Check out these emission factors on the slide. This basically shows how much wear different vehicles generate per kilometer. And as you can see, there is a direct linear relationship between the weight of a vehicle and the amount of tire particulate it sheds. Passenger cars are way down on the low end, but as you move up the scale to heavier vans, buses, and heavy-duty vehicles, those microplastic emissions absolutely skyrocket. Simply put, more weight equals more wear.
So the really crucial point here is how this physical reality impacts our big shift to electric vehicles. Let's compare this neutrally, just looking right at the scientific data. Internal combustion engine vehicles, or gas cars, actually emit 16 to 36% less tire wear in comparative simulation studies. Why? Well, simply because their overall mass is lighter. Battery electric vehicles, on the other hand, are incredible for saving our climate from tailpipe exhaust fumes. No question. But they carry massive, incredibly heavy battery packs. When you combine that extra weight with the high peak torque and instant acceleration of an electric motor, you unintentionally increase the friction on the road. And that means more microplastic tire wear. It's a really complex dilemma, essentially trading one form of emission for another. But hey, it is not all doom and gloom.
Engineers and scientists are on it. They've developed this three-pillar roadmap for mitigation, which you can see right here: prevention of generation, prevention of spread, and prevention of accumulation. We actually have some pretty incredible strategies currently being developed to tackle every single step of this particle's journey.
Let's look at Section 4, stopping wear at the source.
This part is all about what happens right in the driver's seat. Seriously, every driver listening to this explainer can drastically reduce their own invisible pollution footprint today. Just look at these super impactful behavioral fixes. First up, proper tire pressure. Get this, retrofitting vehicles with pressure monitoring systems could save an estimated 100 tons of wear per year just in the Netherlands alone. Next is wheel alignment. Simply making sure your tires are pointing straight prevents 50 tons of unnecessary shedding. Then, seasonal swaps. If you drive soft winter tires in the blazing summer heat, you are emitting roughly 2.2 to 2.7 times more dust. Don't do that. And finally, eco-driving. Smooth acceleration and gentle braking stop those massive friction spikes that literally tear up your treads.
Now you might be wondering, what about the manufacturers? Can't they just make better tires? Well, they face this intensely difficult engineering problem known as the magic triangle of tire development. This principle basically dictates that you cannot optimize a tire's rolling resistance for fuel efficiency, its wet grip for your safety, and its abrasion resistance for lower pollution all at the exact same time without sacrificing one of the others. It's a massive trade-off. If you make a tire solid as a rock so it never sheds, well, it becomes dangerously slippery the second it rains. Scientifically, it is incredibly difficult to just magically create a safe, zero-wear tire.
However, material science is stepping up to cheat this magic triangle. Researchers are developing some truly sci-fi sounding innovations right now. For example, they're looking at replacing standard carbon black with highly dispersible green silica derived from, wait for it, the ashes of rice husks. This dramatically increases abrasion resistance without losing any of that vital grip. There's even advanced research into self-healing bromobutyl rubber. Imagine tires that use butylmidazole to independently compensate for microscopic damage at a molecular level. They basically repair themselves to maintain their integrity and shed far less plastic onto our roads. How cool is that?
Moving on to Section 5, trapping escaping particles.
Since we know some wear is just completely unavoidable, we need safety nets to catch those escaping particles. And we have two brilliant physical interventions on the table right now: active filters versus passive pavement. On the active side, researchers are literally developing wheel arch vacuums. Think of them as aerodynamic systems with little fans that actively filter the air right at the spinning tire. They're aiming to capture up to 90% of the particles before they can even fly off the car. On the passive side, civil engineers are laying down porous asphalt traps. This is a very open asphalt concrete with hollow spaces built in that act like a giant microplastic sponge. They can capture up to 95% of tire wear directly on the highways, which can then be safely cleaned out later by specialized street sweepers. So we've covered the hidden microscopic world of tire wear, the tricky dilemma of vehicle weight, and the incredible material science aiming to fix it all. I want to leave you with this final thought. Next time you get behind the wheel, what kind of invisible trail will you choose to leave behind? Because by just checking your tire pressure, driving a bit more smoothly, and paying attention to your maintenance, you can instantly become part of the solution to one of the world's biggest microplastic problems. Thanks so much for joining me on this explainer today. Stay curious and keep learning.